So now the question 4a of this particular past question says find the polar coordinates of the points A 5 to 3, 5 and 3. Now this is pretty simple. So solving this here, what you just have to do is find for the resultant, then find for the angle, then put them in the polar form. So now I'm going to be finding for the resultant of these two values here. So that is the resultant r is equals to square root of 5 square plus 3 square. That is equals to the square root of 5 square is equals to 25 and 3 square is equals to 9. So 25 plus 9, that is equals to square root of 34. The square root of 34 is about 5.31, something around this value. So now I've gotten our resultant, and now to get for theta. Theta is equals to arctan of minus 1 y over x. That is, the y is the second one, x is the first one. So that is equals to arctan minus 1. Our y is equals to 3, then our x is equals to 5. So arctan of 3 over 5 is equals to 31 degree. So therefore our polar coordinate A is equals to, we have our resultant first, 5.31, and our degree 31 degree. And you can also see it in the form of, square root, the square root here, root 34 and 31 degree. So now the question 4b says that show that the points A 5 and minus 6, B minus 3 and 0, C minus 1 and 2 form an isosceles triangle. This is very simple. What you just have to do is that we will find for the distance between 2 points, point A and point B, the distance between point B and point C, and distance between C and A. Then two of them must be the same thing, while the third one will be different, for we to call this an isosceles triangle. So now the solution, first of all, we are looking for our points A, B, our line AB. So our line AB is equals to the square root of x2 minus x1 square. So this is the x2. We have 5 minus this minus 3 here, so it will become minus 3. If we close the bracket, square, then plus, we have minus 6 here, we have minus 6 minus 0 square. So if we try and simplify it, we have 5 minus minus 3. Minus times minus is plus. That is 5 plus 3, that is 8 square, plus minus 6 minus 0, that is still minus 6, minus 6 square. So we are going to be having square root of 64 plus 36, which is equals to the square root of 100. And square root of 100 is equals to 10. Therefore, we have it here that our line AB is equals to 10. So now let's find for line BC. Our line BC here is BC is equals to the square root of minus 3 minus 1. We have minus 3 minus the minus 1 here. Then we square it, then plus the 0 that is here, 0, that is the second one minus the second one here, 0 minus 2, then we square it. So this is the distance we get, square root of minus 3. Let me try and break it this place down a little bit. We have minus 3 minus minus 1, that is plus 1 square, then plus 0 minus 2, that is minus 2 square. So this is equals to minus 3 plus 1, that is minus 2. So square root of minus 2 square plus, we have a minus 2 square, which is equals to square root of 4 plus 4 equals to the square root of 8. and square root of 8 according to sort form is equals to 2 root 2. So therefore our line BC is equals to 2 root 2. So now let's find for our line AC. Now for our line AC, in order to confirm whether it's totally an isosceles triangle, we have the first one minus the second one here. We have AC is equals to square root of first one here minus the first one here. We have 5 minus the minus 1 there. We put square, then plus minus 6 here, minus 6 minus the 2 here, then we square it. So we just put it as 5 minus minus 2, that is 5. 5 minus minus 1, that is 5 plus 1. So that is equals to square root of 6 square plus minus 6 minus 2, that is minus 8, then square. So that is equals to the square root of 6 square is 36, 8 square is 64. That is equals to the square root of 100. So square root of 100 is equals to what? 10. Therefore our line AC is equals to 10. So since our line AB and line AC is equals to 10, therefore it's an isosceles triangle. So you just write it like this: AB is equals to AC, but is not equals to BC. Therefore, it is an isosceles triangle. So now the question 5a says a particle moves along a curve whose parametric equations are x is equals to 3e raised power minus 2t, y is equals to 4 sin 3t, and z is equals to 5 cos 3t. Find the acceleration at any time t and its magnitude at t equals to 0. So here's how we solve it. It says it moves along a curve with parametric equations of this and this. Now this parametric equation now, which is f of t as a function of time, it will be equals to 3e raised power minus 2ti. That is, this will be the I function, the x will be the I function, then the y will be the j function, that is 4 sin 3t, then plus the z now will be the k function. Okay, 4 plus 3t j, then plus 5 cos 3t k, 5 cos 3t k. So now this is the equation here. So this is the distance. So now in order to get acceleration, we have to get the velocity, and the velocity here, velocity is equals to the differentiation of this equation here, that is f prime of t, which is the same thing as something like dy then dt dx, or dt dx, dt dx, or dy dt, something like that. So when we differentiate this, we have this as minus 6e raised power minus 2t, minus 6e raised power minus 2t. We bring this minus 2 here, that is, then the I will still be there, then plus, when we differentiate this one, we will get 12 cos 3tj, then plus 3 times 5, we have no, it will not be plus again, because cos, the ratio of cos gives a negative sign, so we have minus 15 sin 3tk, minus 15 sin 3tk. Let's put it is a k function. So we are going to be having this our function of this our velocity, but our acceleration now is equals to the differentiation of velocity, that is f prime of t, that is double prime f here double prime of t. is equals to, so we differentiate this one again. We have minus 2 times minus 6, that is 12 e raised power minus 2t of I, then plus, we differentiate this one again, it cannot be plus again, to turn to minus, because when we differentiate cos, it changes to negative sign, so it will become minus 3 times 12, 36 sin 3t j. Then differentiation of sign, that is minus 3, that is 45 cos 3t k, 5 cos 3t. So now we have gotten our acceleration at any time t. So now they ask us to find for the magnitude at t equals to 0. So if t is equal to 0, that means this will be f prime of, instead of t, it will be equal to 0. So we have equals to 12 times e raised power 0, that is minus 2 times 0, which will still be 0. So no, it's not this way. Before we leave it this way, we have to bring minus 2, we have to bring it under, we have to bring it under. So we have it 12 over e raised power 2t, that is 12 raised power minus, the minus is going to come under, so that is equal to e raised power 12 over e raised power 0, this is I. Then we have for sine, we have minus 36 sine 3 times 0, which will still give us sine 0 j, then minus 45 cos 0 k. So now if we try to calculate it, e raised to power 0 is equals to 1. So we have here 12i, then 36 sine 0 is equal to 0. So that is minus 0j. Then 45 cos 0 is equals to 1. So that is minus 45 cos 0 equals to 45k. So now this is the component. So they told us to find for the magnitude. They told us to find for the magnitude. That is the magnitude of A at 0. So the magnitude of A at 0 would be equals to 12 square. 0 square is out. We have plus, we have minus 45 square. Then we look for the square root. So this here will give us square root of 144 plus 2025. So 144 plus 2020. Let me get a little bit more space. So this will be equals to the square root of 144 plus 2025. That is equals to 2169. So therefore, A naught is equals to the square root of 2169, whatever the square root of 2169 is. So in the question 5b here, it tells us to find the distance between point A 2 and 1 and B 5 and 7. So here is the formula for finding the distance between 2 points. The formula for finding the distance between 2 points is square root of x2 minus x1 square plus y2 minus y1 square, all square roots. That is the formula for finding 2 points. So our line AB here will be given as the square root of, what is our x2? We can pick this one as x2. We have in brackets 2 minus 5 here, then we square it, plus our y. This one is 1 minus 7, then we square it. So it's equals to the square root of 2 minus 5 is minus 3 square, plus 1 minus 7 is minus 6 square. So this is equals to the square root of 9 plus 36. And 9 plus 36 is equals to 47. So our distance is equals to the square root of 47. So question 6 here says if r is equals to t cube plus 2t I minus 3e raised power minus 2tj plus 2 sin 5t k, find I the r dt, then the square r dt square, then the modulus of the square r dt square at t equals to 0. So we start one after the other. The first one here, I the r dt. Now the r dt, differentiating this will be equals to 3t square plus 2 raised power I. Then differentiating this to is minus 2 times this, that is plus 6 e raised power minus 2t. Then here too we differentiate this, we have that is plus 5 times 2, 10 cos 5t for k. This one is for j and that one is for k. So this is the answer for the r dt. Now for the square r dt square, we are going to be differentiating this one again. So the square r dt square is equals to, we have this as 6t. This 2 is a constant, so it becomes 0. 6ti plus minus 2 times 6, that is minus 12 e raised power minus 2t of j. Then 5 times 10, that is 50, but cos changing to sign is minus, so we have minus 50 sin 5t k. So now this is the square r dt square for the second answer. But for the third answer here, we have the square r dt square. We should find for the modulus at t equals to 0. So now when t is equals to 0, we have the square r dt square at t equals to 0 first is equals to, when t is 0 here, this one is away, 0i minus, when t is 0 here, we have 12 times e raised power 0, then e raised power minus 0, e raised power 0, then we have minus 5 minus 50 sin 0 k. This is the j function. So this will be equals to 0 here, sin 0 is equal to 0, so we have minus 12j. So now the modulus of this, the square r the t square, the modulus at t equals to 0 is equals to minus 12 square, then the square root. So minus 12 square is equals to 144, and we'll find for the square root. Now the square root of 144 is equals to 12, or it can be plus or minus 12. So this is the answer for this. So now the question 6b says calculate integral from 2 to 1 of r of t dt if r of t is equals to 3t square minus 1i plus 2t minus 3j plus 6t square minus 4t k. So how do we integrate it? So now the integral of from 2 to 1 of r of t is equals to, when we integrate this part, is something like integrating 3t square minus 1i dt, then plus integrating here 2t minus 3j dt, then we have plus integral of 6t square plus 4t k dt, 40k dt from 2 to 1, 2 to 1, from 2 to 1. So now if we are to integrate this, integrating this one here, we have in brackets 3t 2 plus 1, that is 3, divided by the 3, then minus, since 1 is a constant, it becomes t directly. That is this one for I, then plus, on this part we have 2t raised power 2 divided by 2, then minus 3t j, then plus, also on this side we have 6t raised power 3 all over 3, this is not plus here, this is minus, then minus 4t raised power 2 all over 2 of k. So now this is it for now. So we try to simplify 3 divided by 3, that is 1. So here we have t cube minus t of I plus 2 divided by 2, which is 1. We also have t square minus 3t of j, then plus 3 here 1, 3 here 2. So we have this as 2t cube 2t cube minus 2t square, because 2 here goes in 2. So this one is for k. So now this is the normal integral of r of t, that is the normal integral. Now the normal integral from 2 to 1 now is, we put the value of 2 in everything minus the value of 1 in everything. So now this will be equals to, I'll open a big bracket when t is equals to 2. So we have in bracket t cube minus 2 close bracket of I, then we have plus 2 square minus 3 times 2 on this part of j, then plus we have here 2 times 2 cube minus 2 times 2 square of k. So that is for the 2 parts. Then we minus it from the 1 part, that is when it is 1. So we have 1 cube minus 1 of I, then plus 1 minus 3 times 1 of j, then plus 2 times 1 cube minus 2 times 1 square of k. So this is it for the 2 and the 1. So we do this one, then we subtract it from when it is this one right here. So now when it is 2, we continue, we have 2 cube, that is equals to 8 minus 2 close bracket I, then we also have here 2 square, that is equals to plus 4 minus 3 times 2, which is 6 of j, then plus t cube, that is 8 times 2, 16. We have 16 minus t square, that is 4 times 2 here, which is 8, like that is minus 8, and this one is k. So this one is for the 2 side. So minus in brackets. Now this side we have 1 square, that is 1 minus 1, that is equals to 1 minus 1 I, plus 1 in brackets 1 minus 3 times 1, that is 3. Then we have here 2 times 1 raised power 3, that is 2. So we have here 2 minus 2 times 1 raised power 2, that is still 2. Then this one is k, this one is j. So now if we try and expand it a little bit, let me put this there, try and expand it a little bit, we have 8 minus 2, that is equals to 6i. We have 4 minus 6, that is equals to minus 2j. Then we have 16 minus 8, that is plus 8k. Then on this side we have the minus sign, minus 1 minus 1, that is 0. So we have minus 0i. Then minus times, we have 1 minus 3, that is minus 2. So minus times minus 2, that is plus 2. We have plus 2j. And minus, we have 2 minus 2, which is 0, that is minus, we have minus 0 or plus 0. We have plus 0 minus 0 of k. So simplifying it, 6 minus 0, we have 6i minus 2j plus 2j, that is equals to plus 0j, which will be exempted from there, which will be exempted. And then we will have our 8k plus 0k, that is plus 8k. So therefore this is the integral of r of t from 2 to 1, 6i plus 8k. Thank you very much.